Since IQs are normal, we should probably start by drawing a picture. Then we would mark the mean at the center, 100, and we would mark 130 on the horizontal axis. And we would shade the area under the curve, which is greater than 130, to represent the probability that we want to find. To find that area, we use the normal CDF command on the calculator. Remember that second vars gives you the distributions. With the normal CDF prompt, we enter the lower bound of 130, comma, the upper bound, which is infinity, but we could use a really large number like 1,000, comma, the mean of 100, comma, and the standard deviation of 15. When we press enter, we get the answer to be 0.0227, which is about 2.3%. Notice that our answer is reasonable based on our earlier drawing of the problem. Using the central limit theorem, we can answer a new problem. If we have a class of 25 students, we might ask, what is the probability that the average IQ of the class is greater than 130? When we read this problem closely, we see that the difference in this new problem and the previous problem is that here we are studying the average. And since we're talking about the average, we will need to use the central limit theorem. So first, try to think about whether or not this probability would be larger or smaller than the probability of one randomly selected person's IQ being greater than 130. To answer that question, you might ask yourself, what do you expect the IQs of a class of 25 to look like? Will they be high, low, in the middle? Here is a picture of the distribution of the IQs. So think about the average of 25 IQs being selected from this distribution. What do you expect that value to be? If you repeated this process over and over again, what do you think would happen? Well, that is what we did in class when we simulated sampling distributions. Here's the image of the average of 5 samples of size 25. And here is the corresponding histogram of 1,000 sample means. Remember, the central limit theorem says that the distribution of sample means is still normal, has mean of 100, which was the same as the original distribution, but has a standard deviation of 15 divided by the square root of 25, which is only 3. Here is a picture of two distributions on the same graph. The wide one is the original distribution of IQ scores, which has a standard deviation of 15, and the narrow one is the sampling distribution of sample means, which we just found has a standard deviation of 3. Since the area under a probability curve has to be 1, the narrow curve has to be taller to get the same area on the same scale. Going back to the histogram representing the sampling distribution of sample means, you can look at the graph and estimate the probability that the average IQ of a class of 25 people is greater than 130 points. Select the best answer from those given below.